guys, welcome to the first ever interactive stargazing with Lowell Observatory. My name's Haley. I'm one of the educators here at Lowell, and right now you're seeing a live feed from our Giovanni Open Deck Observatory up on Mars Hill. Now, we've got a really awesome program going on for you guys today. If you can see the giant telescope, the really tall one, that's got a red rope on it right now, that's going to be the telescope that we're using tonight. So that telescope is a 14-inch plane wave telescope, and it's got an imager on the bottom. So basically what's going to happen tonight is we are going to move around from object to object, and I'm going to take in requests. We're going to talk about a lot of really cool stuff that's up in the night sky tonight. So if you guys are ready, we can go ahead and go to our first object. So you guys can see the telescope slewing, and that's what we call it when it moves from point to point. And these telescopes are pretty fantastic. They move pretty quickly. We like to call them ninja telescopes because they're really quiet too. So what you're seeing right here is called Castor. Now, Castor is one of the heads of Gemini. Gemini is a constellation. It's actually a zodiac sign. And fun fact, it's my zodiac sign. And so what you're seeing right here is two stars right up next to each other. So although Castor looks like a single star in our night sky, it's actually six stars in three what we call binary pairs. So binary star systems are two stars that orbit around one another, and then planets can orbit around them. So in this case, Castor being a six-star system, those planets would have six suns. Just let that sink in for a minute, right? Because we're so used to thinking about the fact that we only have one sun. The idea of having six suns is absolutely mind-blowing. So that's just the tip of the iceberg with what we're going to talk about tonight. Now, something that's not quite visible right now, it was a little bit ago, is actually Venus. So if we want to take a look at the Venus picture we've got right here, and Sarah is actually the one operating our plane wave right now. Wave hi, Sarah. And so the Venus picture you see here was taken earlier. And you can see that it almost looks like a crescent moon. And that's because Venus actually sits between us and the sun. And so it goes through phases a lot like Earth's moon does. Now, Venus is in a really interesting place along with Mercury today. So if we want to take a look at that Mercury picture as well, these guys are in what is called conjunction right now. So for those of you guys who saw our Venus in conjunction with the Pleiades video, the same thing's happening here with Venus and Mercury. They're not actually super close to one another, but they only look about a degree apart in the night sky. So now that we've taken a look at those guys and we've opened up with Castor, let's take a look at one of my favorite objects in the night sky, and that is M5. So the M in M5 stands for Messier. Messier is a catalog that we use for a lot of deep space objects. So deep space objects, those are things that you can't see with your naked eye. This one that we're going to take a look at right now, M5, is called a globular star cluster. Now, globular star clusters are pretty interesting objects, right? These guys are clusters of about 100,000 stars, and they exist at the edges of our galaxy. So M5 in particular is home to approximately 100,000 stars, and it's about 25,000 light years away. So we can see it start coming in the middle there, that kind of fuzzy haze you're seeing, that's the core of the globular star cluster. And then we're adding on a little bit more exposure time so that we can start to see all of those fainter stars around it. Now, you'll notice throughout the live stream tonight that the images are going to get better and better. And that is because the night sky is getting darker and darker. So right now we're choosing all of those really bright objects in the night sky so that we can get better views right off the bat. So M5 here is also known as the Rose Cluster, and like I said, it's one of the many globular star clusters in the Milky Way galaxy. Now, globular star clusters are pretty fantastic in the sense that they are some of the oldest stars we see in the galaxy. And that brings up some some weird thoughts, right? Because if they're some of the oldest stars in the galaxy and they're at the very edge of the galaxy, why are they there? Well, we actually think that these might be the cores of galaxies that the Milky Way has consumed throughout its lifetime. And we'll actually get to see an act of two galaxies combining a little bit later tonight with something called the Whirlpool Galaxy. So, for those of you guys who are interested in astronomy and you guys already know a lot about really fantastic views. M51, the Whirlpool Galaxy, is one of the most spectacular things to view by far. Now, let's go ahead and take a look at another binary star system called Mizar and Alcor. So, Mizar and Alcor is actually a visual binary. So, what that means is even with your naked eye, you can see both of these stars at once. And fun fact about Mizar and Alcor is they were actually used as an eye test way back when, because if you can see both stars with your naked eye, it means you have close to perfect vision. Now, Mizar itself is actually a six-star system, a lot like Castor, and Alcor is a binary star system. Oh, my bad. Uh, Sorry. Mizar is actually four stars, and so altogether they're like a six-star system, very similar to Castor. And these stars, they are about 83 light years away. So let's talk about what a light year is. One light year is the distance that light will travel in a single year. That distance is 6 trillion miles. Now, a trillion, I mean, what even is that number, right? So let's put it into context. If you were to start counting right now, one number per second, and you didn't stop for breaks or anything, and you wanted to count to 1 million, it would take you about 11 days, which is totally possible, right? Just like chug a bunch of Red Bulls, count your face off, you could do it. But if you wanted to count to a billion, it would take you about 25 years. Now, if you factor in breaks and such, that's essentially a human lifetime. So, probably not possible. If you wanted to count to 1 trillion, it would take you 37,500 years to count to. That's longer than modern civilizations have existed. So, one light year is very, very far. Now, let's take a look at something that is much farther away. Let's talk about M35. So, Sarah, if we can slew over to M35, this is an open star cluster that is about 2,800 light years away. Now, M35 here, an open star cluster, these are very young stars that all formed together. So, so if we kind of zoom out, this is a much wider field of view than Mizar and Alcor were. M35 will start to come into view, and this is one of my favorite open star clusters because right in the center of this cluster is a really red star. Oh, so this is actually a perfect time to talk about our software, Malincam. So Sarah is manipulating our image here, and she had the gain up a little bit too high. So let me go ahead and highlight where gain is, this guy right here. Now, gain, you can think of it as sensitivity. So if the gain is too high, you could see that it completely whited out the screen. So we needed to turn the gain down a little bit. We're going to manipulate our color adjustments so that we can start to see those stars a little bit better. So if we take a look towards the middle here, I'll draw a little circle around it. This little guy right here, that is that red star that I was talking about. Now, red stars are actually the cooler stars in the universe. So it's a little weird to think about, right? Because we're used to thinking red means hot, blue means cold. But it turns out that in astronomy, that's actually the complete opposite, right? So red means cold and blue means hot. Now, the rest of these stars in here tend to be bluer stars when we're talking about open star clusters. And that's because these are typically very young stars that all formed together. So let's take a look at something that isn't a bunch of really young stars, but a bunch of really old stars. So can we get M13, the Great Hercules cluster, in the view here? Now, M13 is another globular star cluster. Now, we talked about M5, that globular star cluster, how they're very old stars. M13 happens to be one of the brightest globular star clusters that's out there. So once we move over, you'll see that we can actually up the exposure time. So the exposure time is right over here. And right now we're at about 6 seconds, right? So what's going to start to happen with all of these exposure times is that down here, you can actually see this bar filling up with the exposure. So once we get all the way up to 8 seconds, we'll start to see the star cluster happening right here. Now, globular star clusters, a lot of them, we actually believe, have something at the very center holding them all together. And that something is a black hole. Now, I'm extremely interested in black holes. You can ask anyone at the observatory, and they'll tell you that it's one of my favorite things to talk about. So, a black hole is basically this teeny tiny little speck out in space that has infinite density, which causes a huge gravity well. Now, what that means in our case with this globular star cluster is the gravity of that black hole is keeping all of these stars in orbit around it. So it keeps it very tight knit. So even though M13 has upwards of 100,000 stars, it's still extremely tight knit, possibly even closer together than some open star clusters. All right, so it looks like we have a request from Rick Taft. He would like to see M51 and M101. Now, we are going to look at both of those objects later tonight, but unfortunately, it's not quite dark enough yet. And so we're going to go ahead and move to M87 first. And M87 is another galaxy, much brighter. And M51 is going to look fantastic later tonight, so stick in with it, Rick. Now, M87 has been in the news quite often. So, M87 is home to a supermassive black hole, and most of the galaxies we've taken a look at have supermassive black holes at their centers. But M87's is the most important currently because back in May of last year, we actually got a picture of this black hole, which we'll show you in just a second here. There it is. So this is the first ever image of a black hole. Take it in, guys. This is the coolest image that is out there. And so what you're seeing here is light that traveled for 50 million years to get to you, because M87 is 50 million light years away. So not only did we get a picture of a black hole, we got a picture of a black hole not in our galaxy from 50 million years ago. I mean, tell me that's not the coolest thing you've ever heard of, right? Now, if we move back over to live feed, you can see that M87 is kind of like a bright spot here, right? It almost just looks like another star. But the cool thing about this is that's showing us just how crazy full of stars this guy is. I mean, this is home to several trillion stars. Our Milky Way galaxy has somewhere around 400 billion stars. So this is significantly larger than our galaxy, which is why we can see it with such clarity, even though it's so far away. Now, M87 is part of a galactic cluster called the Virgo cluster that is home to about 2,000 galaxies. So it turns out that the spring sky that we're in right now is galaxy season. There are lots and lots up in the night sky. But before we get to more galaxies, let's go ahead and try to see one of our nebulas that we have in place for tonight. So Sarah, if you think we can get the Ghost of Jupiter nebula, let's go ahead and try that. It might be too bright out still. If it is, then we'll go from there. But let's go ahead and try for Ghost of Jupiter. So this is the interesting part of astronomy, the waiting, right? We have to wait for it to get dark enough to see these crazy deep space objects. And so let's see if we can try. Oh, there it is. Look at that. So, Ghost of Jupiter, a planetary nebula, this is what's left over after a sun-like star dies, which is a really weird thought, right? How does a star die? Well, basically, every star out there is home to lots and lots of hydrogen at its core. Now that hydrogen, it's moving around super duper fast. So eventually, inevitably, it'll crash into another hydrogen atom. And when that happens, it lets off a little tiny packet of light called a photon. And that little photon will travel throughout the star until it reaches the surface. That process is called thermonuclear fusion. So that is what fuels stars, right? That's what makes stars hot and bright. And so, oh, I have another request. Give me one second. Let me finish talking about this real quick. And so, what happens when a star runs out of that hydrogen is that its core cools down, its outer gases expand, and then it pushes out all of those outer gases in the case of a sun-like star, leaving behind a planetary nebula. Now, planetary nebula is a bunch of gases, and at the very core is a little white dwarf star, which I don't think we can really see here. Oh, wait, maybe we can. If you zoom back in, oh, yeah, that's awesome. So you can see that white dwarf right in here. So that white dwarf star is extremely dense and it's letting off enough ultraviolet light to light up all the gases around this object so that we can see it, even though this is about 1400 light years away. So, Ghost of Jupiter is a pretty fantastic planetary nebula. And I'm actually not up at Mars Hill right now, so I'm not sure if it's dark enough yet. So, this is up to you, Sarah. But do you think we can get the Owl Nebula in? So, the Owl Nebula is too faint. So, about 5 more minutes, and we'll be able to get to the Owl Nebula. But if anyone has any requests, oh, let's see. So we have a request from John Schwartz. Any chance you could show us M61? It has a supernova in it right now. So is M61 within our field of view? Let's take a look. So what Sarah is using right now is the program that we use to move around the plane wave telescopes. And I say telescopes, there's actually two of them, the 17-inch and the 14-inch. The 14-inch is the one that is home to our imaging camera that runs the MalinCam software. And the 17-inch is actually home to our spectrograph, which isn't quite up yet. But we are going to go ahead and slew over to M61. So let's take a look. Oh, we went back to a globular star cluster. So that is one downside of this program is it's pretty sensitive. You have to make sure to get it right on. So let's take a look at M61. So you can see the little green circle moving to the yellow circle. The green circle is where the telescope is. The yellow circle is where it wants to be. So we're going to move over and let's go ahead and up the exposure time. So you can see over to the left there, Sarah put it up to 14 seconds. So usually what we do with the plane wave telescopes with the MalinCam software is we go to the object and we'll set it at an arbitrary number, right, 14 seconds, so that we can get something up to see what we're working with. You can see here that this galaxy is coming into view quite nicely. So if we up the seconds a little bit more, we'll start to see more development happening in here, right? We'll start to see it clearer. And we're looking at this because John Schwartz says that there is a supernova in this right now. So a supernova is what happens when an extremely large star dies, right? So earlier we talked about planetary nebulas. We talked about how smaller stars, they expel those gases, crush in the center. And so what happens with a supernova is it's actually the most violent occurrence out in space, right? It's this huge explosion when an extremely large star dies. And these stellar explosions can create a couple different things. For the most part, they create something called a neutron star. So a neutron star is an extremely condensed, packed ball of neutrons. And when I say extremely condensed, I mean these stars, they have to be at least 60 times the diameter of our sun to go supernova. And when they collapse into this neutron star, they're about the size of Flagstaff, right? These are city-sized stellar objects, which can manipulate gravity quite nicely, right? Everything around it starts to bend. And so That's the first thing that can come from a supernova. The second one is actually a stellar black hole. So we talked a little bit about stellar black holes, or we talked a little bit about supermassive black holes earlier. Stellar black holes, these guys are a little bit less massive, but same idea. Now, I'm not sure which one of these spots would be the supernova. I'm gonna assume, yeah, one of those two that Sarah was pointing out. So either this guy, oh, drew right over it, or this guy. Um, yeah, because supernovas, they, like I said, are the most violent occurrences out in space. And so sometimes they actually eclipse the galaxy that they're in because they're so bright. Now, it looks like we have another request. So it looks like Jim Hendrickson would like to see M104, which is the Sombrero Galaxy. So let's go ahead and try for the Sombrero Galaxy. It should be dark enough to at least see it a bit. And the Sombrero Galaxy holds a place near and dear to our hearts here at Lowell Observatory. And that is because Vesto Melvin Slifer, our second director here at Lowell Observatory, he studied what were thought at the time to be some sort of nebula. And it turns out that these nebulae that he was studying, they were moving really, really fast. In fact, they were moving so fast they couldn't exist in our own galaxy. So that led him to believe they were galaxies of their own. And he started with the Andromeda Galaxy, and he was using something called spectroscopy. Now, spectroscopy, for those of you who haven't heard of it before, is basically the study of light, right? This is how light interacts with things, how it tells us things are moving. And you can take something's spectrum to tell you what it's made of. And you can see here pictured quite nicely the Sombrero Galaxy. This is the second galaxy that Slifer studied using the Doppler effect. Now, the Doppler effect, if you've never heard of it, you've heard it. If a plane, a train, an automobile, something comes by you and you hear that sound as it passes you, right? That's the Doppler effect, right? As that thing comes towards you, it's actually blue shifted, right? So what that means is that spectrum, right, this rainbow bar with dark lines inside of it, those dark lines physically move towards the blue end of the spectrum. And then as it moves away from you, it moves towards the red end of the spectrum. And so Slifer saw that the Andromeda Galaxy was blue shifted. It was coming towards us. And then he looked at this galaxy right here, and he saw that it was red shifted. It was moving away from us. And then he studied many more of those galaxies, and he saw that every single one of them was red shifted. So this galaxy right here was the first evidence of the expanding universe. This idea that everything is moving away from us faster and faster the further we look away. So, M104 Sombrero Galaxy is a very nice edge on galaxy. So, we can see right here that this right here is a dust lane. Now, dust lanes in galaxies, those are the areas where stellar birthing is happening, right? Where stars are being born out of those dust lanes. And then we can see this bulge right here. That's the galactic bulge, the very center of this galaxy. So this is one of the more beautiful galaxies to look at. We'll look at quite a few tonight. Like I said, spring sky is really nice for galaxies. So let's move on to our next request. We have MK Gorman, and they ask, "What, when possible, could you show us M81, 82, or the Leo triplet?" So, do we have M81 and M82 in view, Sarah? You think we can get to it yet? Let's see. M82 might be okay. So the thing with our plane wave telescope and the Godo telescopes is that there's this awesome dome, right? This dome that goes over the entire open deck observatory, and it actually moves on these rollers. The whole building moves, which is fantastic because it means that us educators don't have to go out and move telescopes in and out every night. But it does mean that it obstructs some of the night sky from the plane wave. And so M81 and M82, they are towards the northern part of the sky. They're actually right off of the Big Dipper. And the northern part of the sky is where the obstructed view is. Oh, wow. So this is M82. This is a really cool galaxy. So great request. This guy right here is something called a starburst galaxy. So Sarah, if you could up the saturation a little bit. So the saturation is going to pull out those colors for us. And the reason I want to pull out the colors on this galaxy, also called Cigar Galaxy, is because it is a starburst galaxy. So starburst galaxies, what's happening here is that its companion galaxy, M81 or Bode's galaxy, is actually pulling on M82, and that's causing it to it's causing it to birth stars at over 10 times the rate that the Milky Way is birthing stars. And M81, M82, these guys are about 12 million light years away. And they're home to, well, M82 is home to approximately 30 billion stars. So not quite as big as the Milky Way galaxy, but it's getting there with all of that stellar population. Now, this is also an edge-on galaxy, although it looks very different from the Sombrero galaxy, and that is because it is a starburst galaxy. It's going to have some different properties to it. All right, we're getting lots of requests in. Way to go, guys. Okay, so it looks like, can we get M66, the best of the Leo triplet? Right, so the Leo triplet, 3 galaxies inside of the constellation of Leo. And if I remember correctly, I believe it's kind of towards the tail of Leo. Yeah, so you can see it right in there. Oh, so this is the really fun part of our job. You can see as she zooms in, all of these deep space objects come up, right? You can see that they all have different numbers, different letters in front of them. We talked about the Messier catalog. There's also the NGC catalog, IC catalog, a bunch of different catalogs. And so there are lots and lots of these objects. We just typically look at Messier objects because they tend to be some of the brightest objects out there, some of the brightest deep space objects. Now, Leo triplet, these are 3 galaxies in the constellation of Leo the Lion. And M66, we believe, is the best one. Me and Sarah, anyway. We think it looks really cool. So if we can zoom in there, you can see those beautiful spirals in there, right? So this is classified as a spiral galaxy. Now, spiral galaxies, we've noticed that every single one of them we've taken a look at and really looked at have a supermassive black hole at the center of them. So that looks really nice. Look at that. So just a little bit of manipulation on the image can make all the difference. Now, you can see there's actually some dust lanes going on in the centers of these spirals here. So like I said earlier, that's where all of the stellar birthing is taking place. Now, if you go back down, Sarah, actually, down to the color adjustment so we can take a look, you can see that we can manipulate the hue, saturation, brightness, contrast, and gamma. Now, typically, we only like to mess with the contrast, saturation, and brightness. Sometimes we'll use the gamma. We don't like to use the hue. If you want to move the hue all the way up, let's take a look at what it does to the image here. So you can see it gives it albeit a really cool color, but it's false color, right? So we actually end up seeing the galaxy completely wrong, right? This is just not the right color for the galaxy. Why don't you try going all the way to the other end of the hue? Let's take a look at what that does. All right. Yeah, so you can see all the way from red to blue, right? So the hue is messing up that color there. So we don't really like to mess with the hue too much. All right, so it looks like we've got lots of requests coming in. So the next one is from Catherine Turrentine. Oh, hi, she's one of my coworkers. She would like to see NGC 4147. So is 4147 in the field of view? So you can see that we do, for some of these, actually have to pull up a find target because they are in a little bit of a weird area. And it looks like NGC 4147 is a globular star cluster. So let's go ahead and take a look at that globular star cluster. So we are going to want to turn the exposure time down quite a bit, just because globs tend to be a little bit brighter than galaxies, but we'll see how this one turns out. Like I said, NGC objects are typically a little bit dimmer than Messier objects, so we might have to up the exposure a little bit more. Let's see. Oh yeah, that's a tiny little guy. You want to zoom in on that right there? Oh, that's really pretty. Yeah. I love globular star clusters. I love asking kids what they think globular star clusters look like because you get the coolest answers. I've heard it looks like a dandelion. I've heard my favorite one is a kid actually said when we were looking at it through a telescope, it looked like someone sneezed on my telescope. So kids always come up with the best descriptors of these objects. But great idea, Catherine. I really like this object. All right. So who do we have next? Chris Doby says, can we see Comet Pan-STARR T2? So the thing with comets is we actually have to look them up, typically with right ascension and declination. So right ascension and declination, those are coordinates in the night sky. Since comets move relative to the background stars, we're actually going to have to use the RA-index to find this comet. But if we get it just right, we will be able to see it. Now, comets hold a place near and dear to my heart because, like I said, my name is Haley, and I am named after Halley's Comet or Halley's Comet. My nickname growing up was Haley Bop because a Hale-Bopp comet. So, not that anyone asked, but I love telling people that story. So, let's go ahead and take a look and see if we can find this comet based off of RA-index. So, let's let that exposure run out. And you can see when things are moving, there's like streaks across the sky as stars move in and out of the frame, satellites move in and out of the frame. So once it settles down, let's see if we can find it. Oh, look at that. Nice and bright. Comet Pan-STARR T2. Wow. That is a really nice, beautiful comet. Now, comets, I like to describe them as dirty ice balls flying throughout space. That's definitely not completely the right idea, but that's the way I like to think of them, right? These crazy fast flying through space. All right, so let's take a look. What have we got next? Ooh, okay. So from Zeet, it looks like Napoleon's hat at Arcturus. So, what is Napoleon's hat at Arcturus? Let's see. Um, we are not sure what that is, unfortunately. So, if you want to put in the chat what it is, we'll try and look at it for you. But in the meantime, let's take a look at the next request. We have from book 66, try M83 when you get a chance. So let's go ahead and move over to M83. All right. Oh, southern pinwheel. Okay. So there are a couple of galaxies that we call the pinwheel galaxy. One of the most common is Triangulum, and they're called pinwheel galaxies because they look like pinwheels. So if you guys remember those toys, they have like the stick and then the little thing, and you like blow on it and it'll move around those pinwheels. That's what these galaxies tend to look like. So I've never actually looked at this one before. So let's see what it looks like. It's a first time for all of us. All right. Oh, yeah, that's really nice. Let's go ahead and maybe down the contrast or up the contrast, actually, now that I'm thinking about it. See what that does. So the thing about the Mallancam software is if we make an adjustment, we won't see the difference until the exposure is all the way through. So that's why we had to wait a couple seconds. But we're seeing some nice spiral structures in here. Maybe let's try upping the contrast a little bit more and upping the brightness just a tiny bit. And that's because, oh, that's a lot. And that's because typically when you up the contrast, the image starts to get a little bit darker. So I like to do this to kind of balance it out. So let's see what happens here. We've got that nice bright core right in there. Really, really pretty galaxy. Oh, that made it disappear. So again, trial and error, but let's go ahead and go to the next request. All right. So we've got, don't forget M51 and M101. So do you think that it is Do you think that it's dark enough? Awesome. Okay, cool. We got my chat going up talking to Sarah. So let's go for M101 first. All right. Slewing over. All right. Let that exposure run out. Got an 18-second exposure going on right now. So we're going to see quite a few streaks going across the stream as we move. All right. Oh, it's a real faint one. Maybe down the contrast a little bit. Yeah. Oh, that happens sometimes with the software. If you move the box, it'll actually disconnect from the rest of the screen. So that's always a fun time to deal with. Um, yeah, up in the gain. So the gain again is that sensitivity. So with these fainter objects, you tend to want the gain to be up a little bit. Fun story about me running the Malin Cam one night. I had the gain up to about where it is right now, and I moved over to the moon, and it was just a completely white screen. I couldn't figure out what was going on, and I looked over and I realized that my sensitivity was way too high, so I had to fix that real quick. Um, but let's see what happens here. Oh, that is a really nice galaxy. Look at that. You've got some really beautiful spirals coming in here, right? Yeah. And that's a really bright core too. I like this galaxy a lot. Maybe uh, down the saturation a little bit. Let's see. Usually with saturation, you want it pretty high for nebulae, right? Because it brings out that color a little bit more. With galaxies, it's kind of a case to case basis. Um, but let's take a look. All right. Oh, looks like there's lots of Napoleon's hat requests. So we'll take a look at that next. All right, let's see what happens to our image. All right, yeah. Yeah, so we're seeing those dust lanes in there. Really nice. All right, so it looks like Napoleon's hat is right next to Arcturus, 7-star asterism. All right, so let's go ahead and move over to Napoleon's hat, Sarah. Now it looks like 7-star asterism. So asterism is something that it's easy to spot in the night sky, but isn't technically classified as a constellation. So let's take a look at what this one looks like. I've never actually seen this object, so I think it's going to be pretty cool to check out. All right, so moving over. We might want to down the exposure time, but we can see what happens. Oh yeah, definitely down the exposure time. So this is what happens when you take in too much light on a very bright star. So this star right here is Arcturus. Arcturus is actually one of the brightest stars in the night sky. It's about 30 times our sun's diameter, and it's actually a dying star, a red giant, in fact. So it began its life about the same size as our sun, but its core cooled down, its outer gases expanded, its outer gases are expanding, and eventually they'll push out and become one of those planetary nebulae. So there's another way to up the exposure time also right over here. You can see this is significantly less, right? You can see down here, this is just milliseconds. When down here, we can put it to any matter of seconds. So let's go ahead and look at a couple seconds, 8 seconds, and see what happens there. All right. So there's quite a few stars in here. Um, so we're just kind of guessing because it doesn't technically have coordinates or a name that's in our system. So we are assuming that it's somewhere in here. And it looks like one of you guys gave the coordinates. So let's take a look and see if we can figure this out for you, since everyone's really excited to see this. All right, let's see. Are we moving? All right. think I think it's these guys right in here. All right, so we've got some coordinates down. Let's go ahead and go back to that right ascension and declination screen. There we go. So we're putting in those coordinates that we got from Zeet I hope I'm pronouncing that right. Um, all right. You'll notice that right ascension and declination, they have over to the side these guys. So these are actually in hours, minutes, and seconds or degrees for declination, which I'm not exactly sure why they decided on that, but they did. I wasn't a part of the committee, unfortunately. No, I'm just kidding. That happened a very long time ago. All right. So let's head over to those coordinates and see what we've got in store. Oh, there it is. That's definitely it. Not the streaks, of course. That's just from us moving over. But it looks like that would be Napoleon's hat. All right. Well, I'm learning something new from you guys today. I've never seen this object, and it's pretty cool. Would you look at that? Now, I don't know about you guys, but I don't really see a hat there. Um, that's I mean, I guess, yeah, I guess it could kind of be right there, right? And then like the hat part is right in here, maybe. The face would be here. Oh, it kind of looks like a pirate hat. Okay, cool. I can see that. Nice. Well, great suggestion, guys. I really enjoyed that. All right. So let's take a look. What have we got coming in next? Let's see. Um, all right, from Daniel Oldfield, we have, is Comet Atlas visible? So, Sarah, do you know if Comet Atlas is visible? It is not, unfortunately. It is by the sun. So, it would have been visible in the day, but we would not have been able to see it because the sun is very bright. So, that would have blown out our camera. But it looks like we can go to M51 now, the Whirlpool Galaxy. All right. Oh, I've got some information. It's about 30 degrees from the sun now. So eventually we will be able to see it, but unfortunately not tonight. But we can go see M51, one of the most spectacular looking galaxies out there, because it's actually a galactic collision in process. So, galactic collisions are also known as galactic cannibalism, right? Because it's one galaxy that's eating another galaxy. And earlier I told you guys that we think a lot of globular star clusters in our Milky Way came from an active galactic cannibalism. So, we actually can see these acts of cannibalism happening all the time. So we can actually see the cores of these two galaxies right here. And as we take a longer exposure, we'll start to see the outer disks. And you'll notice that the one on the bottom left is actually consuming the one on the top right. Oh, and it looks like we just posted a blog post about the LDT, our Lowell Discovery Telescope, imaging the comet Atlas. So we're going to go ahead and copy and paste the link into our YouTube chat for those of you guys who would like to check that out. Oh, would you look at that? I'm breathless every time I see this object. I mean, just look at it, how beautiful it is, how you can see the gases and the dust being torn away from one galaxy, consumed into the other one. And the craziest part about this is actually the fate of our galaxy. We are going to combine with the Andromeda galaxy in about 2 days. No, I'm just kidding. It's going to happen in billions of years. So we've got plenty of time to prepare. But it will look something similar to this because the Andromeda galaxy is significantly bigger than the Milky Way galaxy. And so it's pretty much going to tear us to pieces, and we will eventually become one galaxy, which astronomers have decided to name the Milkdromeda galaxy. So uh, that's that's a fun name, right, guys? Milkdromeda. But anyway, I digress. So let's take a look. What is our next request? So we have a couple asking for objects inside of Lyra the Harp. And unfortunately, we actually can't see that from the Givali Open Deck Observatory right now. It's a little bit too low into a tree. So I'm sorry, guys, we can't see Ring Nebula or the Double Double, but hopefully we'll be able to see those eventually from the Open Deck Observatory. Tune in next week, I've been told. We should be able to see it then. All right. So, maybe. so, um, All right, let's go ahead and go to, oh, so we've got NGC 4565. So this galaxy is beautiful. It looks very similar to Sombrero, except you can see a little bit more depth because it's not completely on its side, it's slightly tilted. We can see that bulge quite a bit more. Now, this galaxy is about 40 million light years away, and it's home to about a trillion stars. So, again, this is significantly brighter than the Milky Way galaxy. So, take your last look at M51, beautiful whirlpool galaxy, and we'll move on to an edge on. This is called a face on, by the way. Oh, yeah, there it is. So, you can see that really nice dust lane right in here, right? We can see that galactic bulge very nicely. So we snapped a picture. You can see here, all of these guys up here. These are all pictures we've taken. Sorry about my weird doodle skills. Yeah, NGC 4565. It's also named the Needle Galaxy, in case you were wondering. And you can see this really nice bright spot down here. Oh yeah, that looks really, really good. Way to go, Sarah. Right, snaps for Sarah. Get it? Because we're snapping pictures. All right. Looks like we're getting quite a few requests in here now. Let's see. Yeah, so we've got a couple more for things in Lyra. Like I said, unfortunately, we can't really see that right now. But I do have another galaxy that I personally would like to show you guys, and it's the Black Eye Galaxy. So the Black Eye Galaxy is a really nice galaxy to view. So you can see it's pretty close to the galaxy we're in right now. There's a lot of galaxies down here that you can see. And like I said, the spring sky is really nice for galaxies, lots and lots out there. So let's go ahead and go over to the Black Eye Galaxy. Scooting over. All right. So we've got a long exposure, so we'll see the middle. It'll stop and there'll be lots of streaks on the screen from all of the stars, but we'll get back to it. Let's see, a couple more seconds. All right. So you can see it coming in right now, the sky right here. That's the core of this galaxy. Oh yeah, look at that. So I like this galaxy a lot because you can see quite a bit of contrast in it, right? It looks very, there's a lot of depth to it, right? So we can see these dust lanes in here, making it look kind of like a black eye, right? There we go. That's a really nice image there. Let's go ahead. Yeah, snap a picture for sure. Let's go ahead and go down and maybe up the, let's see what happens if we up the contrast a little bit. So um, I like to mess with the image until I find the way I like it the best, right? Moving around. So that, yeah, that bumped out a little bit of the noise around it. We can see a little bit more. It almost looks like a ripple, right? If you were to throw a rock into a pond, it ripples out. That's what this reminds me of, anyway. So it looks like I've got a request from Empress at Home. Any chance to see the Orion Nebula? So unfortunately, the Orion Nebula is only up in the winter, so it is not quite in the sky right now. And uh, it is really pretty to see, but like I said, right now we mostly have galaxies up in the night sky, but down here, Orion would be kind of over this way, right? Oh, we're moving around. But yeah, unfortunately, the Orion Nebula is not in the night sky right now. I'm trying to clear this off. All right. Do we have any other requests? Yeah, awesome. Let's do the Owl Nebula now. That one that I talked about earlier. It looks like it's going to be dark enough to see it now. Now, the Owl Nebula is another planetary nebula, and the Owl Nebula is very faint, and if it kind of looks like if an owl were to be looking directly up at you, right? So if you were looking directly down onto an owl, that's kind of what this nebula looks like, at least to me, and whoever named it, I'm sure. Yeah, so let's go ahead and down the contrast a little bit, maybe even up the saturation a little bit, since this is a nebula. All right. Let's see what happens there. Yeah, so you can see it right in there. There he is. Let's see what happens when it settles after this next exposure, but you can already see that these are gonna be the eyes right here, the eyes of that owl. So let's see what happens. And you can see that this takes quite a bit longer of an exposure than like the Ghost of Jupiter did because it is a little bit fainter. It's also a lot farther away. It's about 2,600 light years away. So, but yeah, you can see that in there pretty good. Yeah, let's go ahead and up the exposure a little bit more. Take a 31-second exposure. All right. Let's see. And you can kind of see the red along the outside here too, which is pretty nice, right? Planetary nebulas, they are made up of a lot of different gases inside of it. So once this settles up, let's take a look at what is going on. All right. And nice. All right. So it blew it out a little bit, but you can see those eyes in there a little bit better. All right, so it looks like we are rapidly running out of time. Last minute requests. Let's see. Bill McDonald, M106. How about M106? Is that in the field of view, Sarah? Oh, so those are some black hole pictures. All right, let's see. M106. So this is another galaxy. Oh, and Sarah says, "Hi, Bill." So, all right, moving over. And watch that plane wave move. So nice and smooth. All right. So yeah, maybe down the exposure a little bit. Perfect. Exposing, 15-second exposure. All right. Moving up, moving up. Oh, wow. That's a really nice one. Oh my gosh, you can even see it almost looks like the cloud-like structure right in here, right, guys? That's a really nice one. Sarah said Bill always knows the best galaxies. So thank you, Bill, for this idea. Go ahead and snap a picture of that one, Sarah. I like that a lot. All right, so last two requests here. Let's see. We've got Stephanie McCarthy. Have you viewed M13 yet? So we actually did. We did view M13 earlier today, and let's let this exposure run through. Oh, nice. Nice. You can see that center in there really nicely. All right. So we also have Chris Doby, globular cluster M3. And Elron Arrow asked if M33 is viewable tonight, and unfortunately it is not. So check in with us another time. Hopefully we'll be able to get you to see that object. But for now, let's go over to M3, another globular star cluster. All right, M3, if I remember correctly, is also home to somewhere around, I think about 80,000 to 100,000 stars, and it's somewhere in the ballpark of about 25,000 light years away as well. So let's go ahead and see. That's a really nice one. Yeah. Yeah, some beautiful red colors out here. I like that a lot. Now, I think we're about out of time. So if it's all right with you guys, I think this will be the last image we've got for the night. So go ahead and snap a picture, right? And we'll keep that in our folder for later. So thank you guys all for hanging out with me for a while. I really appreciate it. I had a lot of fun tonight. There'll be more interactive stargazing next week, and be sure to tune in for our cosmic coffees on Thursday mornings and meet an astronomers on Tuesday afternoons. Right, Tuesdays 2 p.m. for meet an astronomer, 9 a.m. for cosmic coffees. So thank you guys so much for hanging out with me, and I'll see you guys later.